everyone, you're welcome back to our channel Chemistry International. We are happy to have you back in class today. Please don't forget to like, share, comment and subscribe to our channel. Today, we want to look at identification of anions. Truly, we've done a list of videos concerning this. If you have not watched it, please check the description below. Basically, tonight we are going to be looking at the wet tests. I want to believe that we all know what this is all about. It goes beyond the dry test that you just have to eat the unknown substance, and from the evolution or effervescence of gas, you can depict the anion present. This in particular has to do with, dissolving your unknown salt in water, salt X plus 10 centimeter cube of water, for instance, and then adding different solutions in order to identify what type of anion is present in the unknown salt. So today, I will be happy, like we have always promised, I'm happy to bring to you the mnemonic device. What we are doing in this channel is try to look at the shortest possible way in reaching our destination. And this is what we have done for you today. Of course, the anions we are going to be looking at include trioxocarbonate 4 ion, sulfite ion, sulfide 2 ion, sulfate ion, tetraoxosulfate 6 ion, chloride ion, bromide ion, iodide ion, and hydrogen trioxocarbonate 4 ion. This is our objective tonight. Now, like we have done in cations, that we showed you that we have basically two reagents, two precipitating reagents. For this night, we are going to be looking at 4 different precipitating agents. Of course, apart from precipitating agents that we can use to identify anions, we can also use oxidizing agents, because anions or acid radicals are also reducing agents. So we can also use oxidizing agents. So for tonight, or for today rather, our objective is to look at, precipitating agents that are 4 in number. This reminds me of one just a short story whereby you have in a land where the people in that land are known with sins. Well, the sins, of course, will always come with, adversity, retrogressiveness in the country. But immediately they shun sin, they neglect sin, they begin to see change in their economy. And then this is what I use to capture the mnemonic device for reagents for anions. And this simply is the sin ban. They banned sin in the country, and this led to mass coin. Mass coin in the sense that, money that was being spent in that part of the world at that point in time. The sin ban, that is the banned sin, led to mass coin, massive money, amount of money in the country. So the mnemonic device for the reagents for anions that we are going to be looking at tonight, the sin ban led to mass coin. The sin ban led to mass coin. D is just to make the sentence complete. Sin, silver trioxonitrate 5. Silver trioxonitrate 5. Ban, barium 2 trioxonitrate 5. Barium 2 trioxonitrate 5. In any case, whenever you are using barium 2 trioxonitrate 5, you can also use barium chloride. You can also use barium chloride. Lead, all right? Lead is simply lead 2 trioxonitrate 5. Alternatively, you can also use lead 2 ethanoate, lead 2 trioxonitrate 5, or lead 2 ethanoate. Mass stands for magnesium, all right? Magnesium tetraoxosulfate 6. This is another precipitating agent for anions. So I'm going to be limiting the discussion tonight into these 4 precipitating agents. When I started, I said the mnemonic device is what? The sin ban. You understand? The sin ban led to mass, led to mass coin. All right? You should be asking me, what does this coin mean? Of course, this coin is actually talking about the anion and the property under this mass. The anion and the property under this mass. If you check our video on identification of cations, the shortest possible way in which we can identify cations, we describe this IN as insoluble and this S as soluble. IN, insoluble, S, soluble. So we are towing the same part today. We are towing the same part today. But before we proceed, this cos, or whenever you see cos, know that it is denoting CO3 2 minus and SO3 2 minus. Whenever you see these two, note that it is denoting sulfide 2 ion. Alright? Br denotes bromine, BRO bromine. This is chloride ion and iodide ion. IN, like we have said initially, denotes insoluble. Alright? Of course, I've told you what this means. Whenever you see COS, carbonates 4 ion, tricarbonate 4 ion, sulfides ion. Whenever you see 2, sulfide 2 ion. So we've understood what this is all about. The same band led to mass coin. The same band led to mass coin. Alright, so we know what these precipitating reagents are. Then the next thing we have to know is that what are the anions that these precipitating agents can precipitate out of solutions. Of course, this also have mnemonic device for it. Well, we do not limit our scope to mnemonic devices alone, but with the nature of chemistry, you've got to use something to capture the information so that when you are in exam hall, you can easily reproduce those information with the mnemonic device that you have used to capture it. That is our objective on this channel, all right? To make it easy for you. That's why we call it Chem Easy. All right. So the mnemonic device for in as much as you know what the same band led to what led to mass coin. You know this. Then you move on to the mnemonic devices for the anions that the precipitating agent can precipitate. First of which is cos 2 ins. You know we have SO4 cos. Sine and tan. So we are using cos 2 ins Brooklyn Square. There's a state or a city in the United States of America called Brooklyn. All right. So we have cos 2 ins Brooklyn Square. That's the first one. Cos 2 ins Brooklyn Square. The second one is cos 2 ins Solving Square. Cos 2 ins Solving Square. The third one is cos 4 ins 2 bin square. Cos 4 ins 2 bin square. All right. But from this, actually, we found out what the fourth one would be. All right. Like I said, the same band, the same band led to mass coin. The same band led to mass coin. For the anions, we have cos 2 ins Brooklyn Square. Cos 2 ins Brooklyn Square. Then we have cos 2 ins again, Solving Square. 2 plus 2, we have 4. Then the next one is cos 4 ins 2 bin square. Cos 4 ins 2 bin square. All right. A quick one. This B stands for what? Black. All right. Let me explain what I'm saying on this side of the board. We talk about sin first, silver trioxynitrate 5. However, let us know one thing that I've not said from the beginning of this class is that you are not going to use the precipitating agent, in this case alone. You have to acidify it. Apart from acidifying, you can also do what? You can also add, you can also eat the solution. All right. So for these two guys first, we are going to be acidifying, adding acid to the corresponding solution. All right. So we have silver trioxynitrate 5, then the corresponding hydrochloric acid. Remember, cos 2 ins. For silver trioxynitrate 5, we have cos 2 ins Brooklyn Square. So we are going to look at cos 2 ins. I told you what cos 2 ins means. Cos, anytime you see cos, that is trioxycarbonate 4 ion and sulfides ion. Anytime you see 2, that is sulfide 2 ion. And these guys here, they are white in color. So you have these guys as white precipitates. Whenever you are adding silver trioxynitrate 5 to any of these anion, any salt containing this anion, remember cos 2 ins. The IN stands for precipitates, insoluble. white precipitate. Are we there? White precipitate is observed. Then the S tells us that whenever you had dilute hydrochloric acid in excess, the white precipitate will become soluble. Then we move on to Brooklyn square. BRO stands for bromine. All right, bromine is yellow in color, or we call it yellowish white, or we call it cream in color. So you've got to know the color also. It's different from bromine gas. Bromide ion rather is different from bromine gas. And the last class that we had, we use mnemonic devices to discuss the different properties of these acidic gases, the 8 acidic gases that we have for the limit, for the scope of this class. So bromide ion, chloride ion, and iodide ion fall into the same category. In silver triazonitrate 5, they are insoluble. It simply means they are going to give you the corresponding precipitate, the color, the precipitate of their color. What that simply means is that when you're adding silver triazonitrate 5 into a salt, a solution containing an anion of bromide ion, you are going to be having yellowish white precipitate that is insoluble. Of course, then in essence, that is the second in, the precipitate remains. This is white in color and this is yellow in color. Iodide ion. All right, so we are done with silver triazonitrate 5 ion. All right, same. Then we move on to barium 2 triazonitrate 5, or barium chloride. Note, whenever you are using barium 2 triazonitrate 5, the corresponding acid that you are going to use have to be triazonitrate 5 acid. Whenever you are using barium 2 chloride, or barium chloride, the corresponding acid should be hydrochloric acid. All right. Then we talk about the anions and their property under barium triazonitrate 5. The anions, like I've told you what this cos2 means. This cos, anytime you are saying cos, it means carbonates and sulfites. Anytime you are saying 2, it means sulfide. So it means in this guy, in barium triazonitrate 5, these guys, apart from knowing their color before now that they are white, they will be insoluble in this guy. But when you had excess acid, they will be soluble. When you had excess acid, they will be soluble. I think we understand that. Then this guy also, solving square. The solving, I believe you should know what that means. Sulfates, tetrahydrosulfate, 6 ion, SO4, 2 minus. When you had barium nitrate into a solution containing this anion, you are going to have white precipitate. It's also white. In excess, instead of the precipitate in excess hydrochloric acid or in excess triazonitrate 5 acid, instead of the precipitate to be soluble, it remains insoluble. This declassifies sulfates, all right, out of the family. It declassifies sulfates out of the family. Instead of it to be soluble, it is rather going to be insoluble. All right, it is rather going to be insoluble. So basically, we are done with silver nitrate, and we said the same band led to mass coin. We are done with silver nitrate, and then we are done with barium nitrate. I told you earlier on, ab initio, that basically what we are dealing with are these 4 reagents: barium nitrate, silver nitrate, lead nitrate, and what? Magnesium sulfate. All right, and then I told you that silver nitrate and barium nitrate, the two, we are going to be considering them when they are acidified. But for the rest two, we are going to be considering them, we are going to be using them as a precipitating agent. Their reaction with the anions when they are cold, and their reactions with the anions when you heat the solutions altogether. So these are just the last 2 reagents, the lead nitrate and the what? Magnesium sulfate. All right. Remember, we said that as for the anions and their properties, we have we looked at SOCATOA cos, and then I said cos2 is Brooklyn square, cos2 is solving square, cos4 is what? Tubing square, cos4 is 2 being squared. So for lead nitrate, we're going to look at cos 4 ins. Cos 4 ins, these are cos, carbonate, sulfite, 4, sulfate, alright? Sulfate, 4 ins, cos 4 ins, meaning that the ins is what? Insoluble, alright? The ins, anyway, is insoluble. Meanwhile, the C here is chloride ion. It therefore means that you can use barium nitrate, you can use lead nitrate to indicate or to identify if there is the presence of chloride ion or not. So this in, they are 2 times repeated, okay? Insoluble. So cos 4 ins. So cos 4 in. All of these cos 4, they are insoluble. Meanwhile, ins, this one is insoluble and then soluble. It therefore means that cos 4, carbonates, sulfites, 4, sulfate, they are all insoluble. Whether in cold lead nitrate or after eating it, they are insoluble. Ins, C, insoluble and soluble. It means that it is white precipitate. When we said insoluble, we are talking about precipitate. If you are reporting your analysis, you are not going to use insoluble, rather you are going to use a precipitate. Alright? But for brevity's sake, for the sake of this class, we are using insoluble. You have to change it to what? Precipitate. So chloride ion, alright, cause 4 ins, insoluble. While precipitate, when you heat it, it becomes soluble. Alright? And 2 being squared. I told you whenever you see these 2, indicates sulfide ion. Alright, sulfide 2 ion. Black precipitate. In square means that it is insoluble when it is cold. It remains insoluble even after heating it. Then we have the last one, magnesium sulfate. Alright, we said the same band led to what? Led to mass coin. Magnesium sulfate and carbonate insoluble. Alright, this also will be considered when it is cold and when it is heated. When it is cold, if it turns white precipitate, right, insoluble coin, alright. If it turns white precipitate, then it is indicating the presence of carbonate ion, triazocarbonate 4 ion. When you heat it, if it doesn't form precipitate when it is cold, then you now heat it now forms precipitate, hot, H for hot, heating. Then it's showing you that what is present in the unknown substance is hydrogen triazocarbonate 4 ion.